Hello everyone, welcome back to my channel. So in today's session, we will be discussing the algorithm where we will see how to find the greatest common divisor of two integers. So given any two integer, design an algorithm for find the greatest common divisor, that is the GCD of two positive non-zero integers a and b. So this is what is the given problem statement is, where we have to find out the common divisor. So before we get on to understand how exactly we can build the steps for this, first let us see what is a common divisor means. Let me take an example, 13 and 48. So when I talk about this 13 and 48, first thing is I will write what are the numbers which can divide this particular numbers. For example, 13 is divisible by 1 and 13. Similarly, 48 can be divided by 1, 2, 3, and 4, 6, 8, 12, 16, 24, and 48. Okay, so these are all divisors. Now, if I'm talking about, I know that this is the divisors of 13 and these are the divisors of 48. Now, I'm looking for greatest, okay, common divisor of two numbers. So these are the two numbers. So which is the greatest as well as common. Now, as you can see, the common here is 1 and 13 is not available for 48. Hence, 1 becomes the greatest common divisor of 13 and 48. All right. So this is how your this is what is the meaning of a GCD is. Similarly, if I were to take some other number, let me just take 10 and 20. Very simple example. We know the divisors of 10 are 1, 2, 5 and 10 itself. Similarly, for 20, I can say 1, 2, 5. We have 4 as well, and then 10. And then I can say 20. So in this case, I have what is common. I do have 1 common, I have 2 common, I have 5 common as well as 10 common. But we are looking for greatest, hence 10 becomes the GCD of 10 and 20. Okay, so this is what the basic logic about GCD is. Now, how do I determine? How do I find out the GCD of any two numbers? There are n number of logics for that. Few of them are prime factorization method, a long division method, which you would have done in your high schools. And also there is something called as Euclids algorithm. So today we will be looking at Euclid's algorithm and we will try and understand how can one find the GCD of any given number. All right. So let us take an example. So the example what I'm going to take is, so before we get on to the example, once again, we have discussed a modulo operation. So modulo operation is something which we are going to be using in this algorithm as well. Now, what is this mod operation? It does, like I told you, it always gives us the remainder. So for example, if I have to say 10 mod 2, which means 2 divides 10 completely. So 2 5s are 10 and the remainder here is 0. Similarly, if I had to say 10 mod 3, here 3 divides 10 3 times and there will be a 1 remainder. So mod operation will return 1. So whatever is the remainder is there, that will be returned, not the quotient. So that is the operator once again we will be using. This particular operator has been discussed previously also. All right. So how does the Euclid's algorithm work? Now, Euclid's algorithm follows a simple method. For example, let me take a bigger number, or let us take a smaller one as of now. So I will take 64 and 40. I have to find out the GCD of 64 and 40. So instead of going ahead and finding the divisors of each one of them and then finding manually which is the greatest common divisor, I am using the modulo operation here. So according to Euclid's algorithm, we will take the bigger number as A and I will take a smaller number as B. Now I will find A mod B, which in our case it is nothing but I will find out 64 mod 40. So as we all know that 40 divides 64 once and 24 is the remainder. So now this is what we get. Now once you complete the first step, if the remainder what you get, if it is not equal to 0, then you are going to go ahead and say So the remainder you're going to store it in a variable called as r, and then you will check whether r is equals to 0. If it is false, then you will swap the values. That is, now you will store the value of b, which is 40 in a, and instead of b value, you will store the value of the remainder, which is 24. And once again, you will repeat the same step, which is a mod b, which is nothing but 40 mod 24. And once again, it is not going to completely divide the value. Hence, the r value, what we are going to get is 16 here. Okay, which is once again not equal to 0. Hence, I will once again change the value of a. Now, a will get the value of b, which is nothing but 24, and b will get the value of the remainder, which is nothing but 16. Once again, we will repeat the step where I will do a mod 16. Here, 16 will not completely divide, and then 8 is a remainder. Once again, which is not equal to 0, I will repeat the step where I will say a is equal to the b value and b is equals to the value of r, and again a mod b. So in this situation, I will get 16 mod r value was 8, so 8. But here if you see 8 divides 16 completely and I will get 0. All right. So this simply says, according to Euclid's algorithm, that whenever a value, b value, when it completely divides the a value, that itself is the greatest common divisor of those two numbers. So according to this algorithm, 8 becomes the GCD. All right, this is as simple as that. So let us quickly see the algorithm, and then along with the algorithm, we will do one more example. All right, so algorithm find the GCD of two numbers. So initially, I will start with declaring the variables a, b, and r. After that, we will read two values a and b. So let me take a bigger value this time. So I'm going to take the values a is equals to 741. And let me take b is equals to 285. So you can do it along with me. So always remember this particular algorithm always takes a bigger value for a. So in that case, you can also add one more line where you're checking whether a is greater than b. So if then you will continue. Otherwise, you can just simply swap the numbers and you can go ahead. So, and also initial condition we have is if a is equal to 0. If one of the numbers is 0, for example, if it was 0, 285, then obviously the greatest common divisor will be 825. Reason being, any number is divisible by 0, or it is a divisor of 0. That is the reason. Whenever you have any one of the number is 0, the other number becomes the greatest common divisor. So that is the first condition. Otherwise, suppose the b value was 0. If it was 741, 0, in this case, of course, 741 will be the output where 741 becomes the greatest common divisor. All right. So now let us go ahead and take an example. So in our case, both the values are not 0. Hence, what we are going to do is we will go ahead with the algorithm. All right. So here, so this is a condition if one of them is 0. Otherwise, what we will do is repeat below steps until remainder becomes 0. So that is what we are going to check. So what are we going to do? R is equals to 741 mod 285. So R will have the value whenever 285 divides 741, whatever the remainder is there, that will be stored. Here in our case, it is nothing but 171. After that, what we are going to do is a value will be swapped with the value of b, which is nothing but 285, and b value will be swapped with the value of r, which is nothing but 171. Next step, we are going to continue these three steps until our remainder becomes 0. Hence, so this is my first iteration. Second iteration, I will go ahead and I will say 285 mod 171, which is nothing but 114. So this is the R value. Once again, R is not equal to 0. Hence, I will change the value of A. A becomes 171 and B becomes 114. So the third iteration, what I'm going to do is 171 mod 114. Now, as you can see, 114 divides 171 once, and there will be remainder of 57. So this is nothing but your remainder, which is not equal to 0. Hence, I will go ahead and swap the values. A will become 114 and B will become 57. Hence, the fourth iteration, I'm going to divide 114 mod 57, which is nothing but when I do the 57 twos are, if you see 50 plus 50 is 100 and 7 twos are 14, hence it is nothing but 0. 0 will be the remainder as 57 completely divides 114 twice. 57 twos are 114, hence R value becomes 0, and the moment R value becomes 0, we will this condition becomes true and we will come out of the loop and then we will return the value of B. Okay, so in this case, the value of B is 57. Hence, the GCD of 741, 285 is nothing but 57. So this is the Euclids method in order to find the greatest common divisor of two number, and this is the algorithm for the same. I hope this is clear, students. If you need any clarification, kindly comment in the comment section and I will try to clarify it. So that's all in today's session. Thank you for watching.